Okay, so the next question that we got on the menu today is what is a Newton? Units and explanation. So let's just get it started. A Newton, named after Isaac Newton, believe it or not, is a unit of force. Comes from Newton's second law. Oops. Come from second law, Newton's second law. F equals ma. Okay, so this is like one of the most important equations in all of physics, is F equals ma. So this is the force, this is the mass, and that is acceleration. Okay, so we know that newtons is a unit of force. 1 unit or 1 Newton is, let's multiply a mass and an acceleration together to get like a unit of force, to kind of see what properties need to be combined in what way for this to be true. Okay, so we have a mass. Here we have a force. And they're equal to each other when they are multiplied by an acceleration. Okay, let's just copy this and move that down. Another way that we can write acceleration is like this. We can do velocity per time. The change in velocity over time is acceleration. That could be another way to write this out. And we can expand out the velocity into something bigger as well, or something more low level. All right, so we just copy this down, and we know that let's get rid of velocity. We know that velocity is just going to be distance over time. And distance over time per time, that's the same as saying this. Okay, let me find my mouse. Ooh. Let's keep that. And for the distance over time per time, that could be written like this: distance over time squared, right? Because a over b over c is equal to a over b times 1 over c, which is equal to a over bc. Okay, that's just like how that works for like triple decker fractions. And let's substitute these out with or substitute in SI units. SI stands for Système International. It's a system or an international like science and engineering standard for units. So here we're going to have Newton. I'll write them out in full, and then here we have kilogram for mass. Oops, kilogram. And then here we're going to have meter. And here we have second squared. And to write this out in symbols, we have 1 Newton equals 1 kilogram per meters per second squared. Okay, so that's what a unit is. A unit, that's the units of a Newton. It all came from his Newton's second law. Force equals mass times acceleration. And once we have that, we can derive the units of it just knowing like mass and acceleration, what they are. And we can break down newtons into its base SI components. Okay, so exactly kilogram meters per second, and it comes from F equals ma Yeah, that's good. So the above solution is good. Is good. Don't use capital K in kg for kilogram. Okay, that's just a minor thing, but still.